We're going to find the oblique asymptote, if it exists, of this function. Now what we have to do to determine if it exists is to look at the degree of the top, which is 4, that's the highest exponent, and the degree of the bottom, which is 3. Since the top is 1 more than the bottom, that means we do have an oblique asymptote. Now I would like to use synthetic division, but since this is 4x cubed and not just plain old x, I have to use long division. Long division. So that means I'm going to write 8x to the fourth minus 2 inside or underneath the radical, or the square root sign, the dividend. So we have 8x4, and I'm missing an x cubed, so I'm going to use 0x cubed. I'm missing the x squared, so I need a 0 there. I'm missing the x, so I use a 0 there, minus 2. Then on the outside, I'm just going to use 4x cubed minus 2. I don't really worry too much about the missing terms there. So I'm using long division. So let's divide first terms only. 4x cubed into 8x to the fourth. 4 goes in 8 2 times. Those 3 x's cancel 3 of those, leaving x, so we get 2x. It's always good when it comes way over here. Multiply 2x times 4x cubed, and we get 8x to the fourth, which you better. And then 2x times negative 2 is negative 4x. Now we're going to subtract. Put the minus sign in, put the minus sign in. Those become 0, which they better. 0 minus negative 4 is positive 4x, bringing down the minus 2. You want to divide 4x cubed into 4x and see if it goes evenly, which means you don't get a fraction. Those cancel. But when you cancel the x with that x cubed, you have x squared on the bottom and a 1 on top, which means it doesn't go evenly. So what that means is this is a remainder, but we don't care about the remainder, or part of the remainder anyway. Well, that is the remainder. We don't care about the remainder. All we care about is the quotient. So therefore, your oblique asymptote is y equals 2x. It's a line. Y equals 2x.